Welcome. There's one more problem that I actually meant to do on the previous video, but in lieu of keeping time down and not overwhelming you with 3 pop quiz problems in one video, I decided to do it as part of this video where we would actually get into calculating molarity as well. So without further ado, let me actually put the problem up. I want you to pause the video. You've got 4 choices. Read the question and pay attention to how this particular question looks different than the previous 2 questions. In the previous 2 questions, only the compounds are different, but the idea was exactly the same. In this particular problem, there's a slight difference in the way the question is worded. Let me see if you can pick it up. And if you have picked it up, give it a shot. You know, we've done something like this. So give it a shot and then pause the video and then continue watching it to see if you did it right. Well, I've already calculated this molar mass and I've shown you how to get it. Manganese is Mn and the 4 goes with the manganese and it's a metal. Chlorine is 7, so 8 minus 7 is 1 and it's a non-metal. So we swap and we get MnCl4. Again, I would purposefully only give you names 99.5% of the time. So if you don't know how to go from here to here, you have to go back to that video where I have explained it. All right, and I believe I've shown you this to be 195 grams per mole. That's the molar mass of this this MnCl4. Now what you need to do is, whether it's moles of Cl or moles, it doesn't matter. We're going from grams to moles, which means our liaison is molar mass, through which we're going to go from grams to moles. So we're going to start with 2.5 grams, okay, and put the 1 on the bottom. This is given information and there's nothing really you can put here. Now this is, keep in mind, this 2.5 gram is for the MnCl4, for everything, right? And then the molar mass is also for the MnCl4, right? At this point, you can do 2 things, okay? You can stop right here, okay? Because you're comfortable with that. I'm going to show you 2 methods, see if any of those methods impress you. So that's 0.012 moles, okay? This is for the entire compound, number of total moles present in the entire compound. But I'm asking you, how many moles of Cl? How many Cl are there in the molecule? There's 4. So just simply multiply by 4. So that'll be times 4 is 0.0512. And that's the answer. Now there's another way to set it up, which some people might find. Again, there's 2 sets of people, at least in this type of problem situation, where some people prefer everything in the block format. Some people prefer the top method, which I've shown you. This is again for the ratio is 1. The whole thing is MnCl4 is 1, right? It's 1 compound, right? So it's 1, and the ratio is 1 to 4. For every one of this, for every 1 MnCl4, you've got 4 Cl. That's what it means, okay? That's how I get the 1 to 4, and you'll still get the same answer. You pick and choose which method works best for you, because there is a concentration problem that we will learn that it will involve this concept. All right, so molarity, as I said, is moles of solute over volume of solution in liters. It's important, liters, so the unit is moles over liter. And here's the problem. Determine the molarity when 2.5 gram of lithium oxide is dissolved in 250 mils of water. So your lithium oxide, whatever your chemical is your solute. And in this case, your water and the lithium oxide, when combined, becomes your solution. So your lithium oxide, Li2O, I'll show you again, plus water is your solution. I'm just visually teaching you that concept. All right. So first thing is you got to figure out the moles of the solute, which means first you got to convert this to a formula. I've already given you that, but lithium is an alkali metal, so it's 1 and it's plus because it's a metal. And oxygen is 6, so 8 minus 6 is 2, and it's a non-metal. We swap, we get Li2O, and I believe lithium's molar mass is 7, so 7 times 2 is 14, plus oxygen's molar mass is 16, so 30 grams over 1 mole. As always, see, what we're really trying to do is do 2 separate calculations. At least that's the way I'm going to show you until you get comfortable with it. Then you can do it all in one step. But what we're really trying to do is find the moles of solute and find the volume of the solution separately. Okay, so that means we're going to first get the moles of the solute. So the 2.5 grams goes on the top, 1 goes on the bottom. We're trying to find moles, right? So the 30 grams goes on the bottom and the 1 mole goes on the top. So basically it's 2.5 over 30 is 0.083 moles. What we have just done is calculate the numerator. We've just done this. We have to calculate the denominator, but the key here is the denominator is in liters, but what we are given in the question is in milliliters. 1,000 milliliter is a liter. Okay, so 250 mils would be, there are so many ways. I've seen people do it. I still prefer to do it my way. You may do it slightly different. So this is 1,000 mil is 1 liter. So that's 0.250 liter. I've also seen people do it this way. 250 mils would be simply 250 times 1 over 1,000. It's all the same. However you want to get it, make sure you get the answer in liters. So this is mils, this is mils. So the mils and mils cancel out, either method you use. The answer is the same. We know our numerator, we know our denominator, and the unit actual way of defining molarity is uppercase M, which means molarity. So it's 0.083 moles over 0.250 liter. You see, we got our moles over liter unit back. That means we're on the right track. So divide by 0.250, and the molarity is 0.333 moles over liter. Or you can also write it as 0.333 uppercase. Yeah, they both are right. You might see this 2 different ways, but I have tried my best to keep this as simple as possible. At times I will give you the formulae, but most of the time I will only give you the name and you have to come up with the formulae. And that's all I had to say about molarity. Stay tuned for a video on molality.